Good morning. This is Dr. David A. Padgett. This is this is Weather and Climate. Geography 3500, spring semester 2021. Today is March 30th, and I'm going to share my screen. Okay, so we have a lot to do today. Today we will be looking at something interesting. We every now and then in this class, a weather event will occur and we will take a look at it. So at some point today, we're probably going to start off talking about this rain event that happened in Nashville over the weekend. Unfortunately, 4 people lost their lives. And so we're going to look at that because this is a weather and climate class and we need to look at that. And then we will, getting into the March 10th week 10. And so again, we'll talk about the March 27, 28 flood event that occurred over the weekend. And then we're going to get into a lecture about flood hazards and storm runoff estimation, perhaps. And I'm going to do a presentation on GIS based assessment of community vulnerability to extreme weather events that's related to the events over the weekend. Perhaps later on in the week, Thursday, the lecture will cover tropical storms and hurricanes. We're not in hurricane season yet, but it's something that we should definitely take a look at given the events of this week. And the assignment for this week, we'll talk about that at the end of the class period today. But first, let's take a look at the, let me stop my share for a moment. Go into the Dropbox and look at some of your results of the U.S. cities climograph. So let's see, I have some results here. And this is from Garrett Ross. He's here today. So I'm going to share my screen again, take a look at what we have here. And so, let's see, what's this? I guess this is the assignment working sheet. Okay. Okay, so we're going to look at Garrett Ross's work again. If you're listening to this recording and you've done your city, you're done. There's no point in doing all 6 cities. I apologize for that. Like I said, I'll be so glad when we start meeting face to face again. We don't have this miscommunication. But in the future, if there's any confusion, just ask me. As soon as you saw this one said 1 city and this one said 6 cities, just pick up the phone. Chances are there's always something that's not going to go right in this COVID experience we're having. But you got extra practice working on these. There's nothing wrong with getting extra work done. So we're going to look at Garrett Ross, who went above and beyond the call of duty. And so let's look at his working sheet here. This is great. This is what we would normally do, is all 6 cities. So so Garrett, which one of the cities was did you use your hometown? Are you Memphis? Oh, Nashville. Good. Okay, so you got Nashville. So so Garrett has all of his data here, as you can see. And okay, so then of course he did all 6 cities. Wow. So okay. And so let's go to, I think this is the assignment itself. Okay, so his data clearly is complete. And let's go back to the working sheet. So the, no, not that, this. So let's see. Okay, so here is the, I guess, step 1. This is step 1. Okay, so this, at this point, this is the, obviously the portion of the assignment where you were to do the Kirkland climate classification, and it's fine. Well, it's not fine. I'm not gonna even say it's fine. So if you go back to the instructions themselves, and the reason that we have to get this right is because this is what goes into your term paper. So if you see sheet 3 here, again,
Can't really see anything.
excuse me.
Can't see nothing.
I'm
You're
sorry,
not sharing your
screen.
screen.
Sorry about that. I'm here talking to myself. Okay, so here we are at, you know, the steps for coming up with the 3-letter Kirkland climate classification. So so here is what Garrett Ross has, so which is a very condensed version. So all I'm asking is that for your term paper, remember this part of this, the objectives of you completing this assignment is it essentially provides content for your term paper, sections 4 and 5. So the goal was for you to do this assignment and essentially just, I don't want to say copy and paste, but insert and then maybe augment the content as part of your term paper. You know. So all it has to be done here is just to take this paragraph and then flesh it out so that it more closely resembles these steps. And like I said, it doesn't have to be at this level of detail, obviously, because these were instructions for an assignment. But so for example, you know, Ross did, you know, start off with his calculations, even distribution of precipitation. So that's step 1. Then he goes straight to step 5. So all you have to do is just fill in. We obviously had to go through these steps, and you can even get a screenshot of what graph you use from one of the other sheets and put it in there as a figure. In other words, because this is a science-based assignment, your methodology section should be replicable. In other words, if I wanted to go through the same process that you did to come up with this humid subtropical CFA designation, I should be able to read your instructions just like I was able to read these instructions and come up with the same answer. So just think of your methodology as an instruction manual for the next scientist who wants to perform the same experiment that you did, because this is essentially an experiment. You're taking data, raw data, and you're analyzing the data and coming up with the result. Okay, so that's essentially what you're doing here. So getting back, case in point, or getting back to that point, let's take a look at the term paper instructions, which are in the syllabus. And so here are the term paper instructions again. Yeah, so like I said, I've had to change this term paper because it would be very difficult for you all to do group work remotely. So it used to be that everybody would contribute to this term paper as a group assignment, but we know we can't. Well, we could try it, but I don't think we would be successful. So I said, just analyze the climate for your own city this time. I changed it, but anyway. So in the last assignment, you should have at least started with content for the area description and climate description. And I think I went over a couple of people's results and recorded that, just to give you an idea of what should be in the area description and climate description. Now, sections 4 and 5 are essentially, notice the key word here is methodology, carbon climate classification with methodology. So we're basically following a science research paper format. Start off with the purpose of your study in the first part of the paper. Obviously, the purpose in this case is to determine the quantitative and qualitative characteristics of your hometown city climate. And you might even include, the Köppen climate classification system and climograph analysis. And that would be in the first part of your paper, that first section. But then again, when you get to these sections 4 and 5, this is where you get into the methodology. So that those several steps that I just mentioned related to coming up with your 3-letter Köppen climate classification. That is what should be in section 5. And you can use this exact same section heading. So that's what should be here. Step 1, step 2, step 3, step 4, step 5. Here's the Köppen classification for Nashville, Tennessee. And that's it. That's what should be here. And again, someone should be able to read your methodology and do the exact same thing. So if you notice here, and again, this is just constructive criticism. I know you all tend to get in your feelings when I start talking about your papers, but I just want you to be better. That's all this is, So notice here, if I was to read your instructions and I was to go from this part, okay, even distribution, and then I go, wait, where's other steps? So just fill in the other steps. Although you did a lot more than is called for here, you still have to go back. You already did the steps, so you just have to write them down. That's all. Just this is commendable work. Just again, in the future, if you see anything that's confusing, just ask me right then and there. Just call, email. Don't guess. That's not the way to go. But like I said, this for Garrett Ross will go a long way. He probably actually will have a better result, at least for this assignment, because it was a deeper level of analysis instead of just doing what was instructed. So he got to do all the cities and do it. Actually, Ross will be a lot more prepared for the final exam than everybody else because he went through this process. And you will see on the final exam that this process will be there. So don't feel bad, Garrett. Trust me, when you get to the final exam, you'll be like, oh, I'm glad I did this. As opposed to others who didn't get that practice in. So, okay, so let's go to the next portion. Which were the climate graphs. And so it's clearly got his climate graph here. Okay, and so next part is, of course, the map. Let's see, climate graphs map. So he's got his link here, story map. Okay, I don't think I can change the format here, but anyway, this is what it is. So as you can see, wow, this is a great job. I mean, this is great. A lot of students are not able to do this, So he's got all 6 cities on the map, including Nashville. And so let's see. Nashville. So, right, he starts off with the climate region and says the climate is affected by the Cumberland River. Yeah, okay. I wouldn't disagree with that. Yeah, I mean, certainly the Cumberland River does provide some form of an urban microclimate that might, it's perhaps, but in terms of when climatologists describe the characteristics of land-water interaction, when you saw the climate control, the land-water interaction, climate control, that really pertains more to very large bodies of water. So for instance, Cleveland, Ohio is impacted by Lake Erie. It's a very interesting scenario here. So here's Lake Erie, here's Cleveland, which is on the leeward side of the lake, and then here's Detroit, which is on the windward side of the lake. So prevailing wind direction is westerly here. Now, one would assume that Detroit, being higher in latitude, would probably have higher or at least equivalent snow amounts to Cleveland, Ohio, but that's not true. Even in terms of the temperature, I think if we did the Köppen climate classification for Cleveland versus Detroit, I believe Detroit would come under the CFB, not CF. No, excuse me. Detroit would be DFA. Excuse me. With the A symbolizing or representing hot summers, whereas Cleveland would most likely be DFB, which is a temperate or continental climate with a cool summer. And so that's the effect of Lake Erie. Lake Erie is one of the largest freshwater bodies in the world. Notice how large it is, even larger than the footprints of the cities, right? So that lake effect definitely is there. Also, with regard to snow amounts, I mean, this snow belt on the leeward side of Lake Erie is pretty famous. I mean, cities like Albany, Buffalo, Lake Ontario, Lake Erie get a lot of snow compared to places like such as Detroit. But for Nashville being affected by the Cumberland River, there might be a there might be a microclimate effect, but if you notice, compared to the size of Lake Erie and Lake Superior and so on and so forth, the Cumberland River just really doesn't have that coverage. So we don't, like I said, on a microclimate basis, on any given day, I would even say micro weather. So on any given day, if we were in downtown Nashville and then maybe walked out towards the Greenway that's right on the river, it might be a little windier by the river than it is farther into the city. But I don't know. But I wouldn't say that Ross is wrong there. Let's see. Very good job here. He has the data, average temperature. He's got the temperature range there. He has the precipitation. So he pulled those long-term data. I would strike this only. Again, try to stay away from qualitative terms. Only 597 feet. If you were to go out to Percy Warner Park and hike and go from maybe 300 feet above sea level to 800 to 900 feet above sea level, I don't think you would use the term only there if you were actually walking uphill. I've done that. It's, yeah, you climb 600 feet, you're going to feel it. So, just stay away from qualitative terms like only. It's fine. Yes, there are no oceans, common disasters. So this is a good description of the climate of Nashville that you can add to that section 5 as a more quantitative based description of Nashville's climate. And of course, the quantitative description that includes climate controls. And so the word climate controls for Nashville or climate controls for whatever city should be spelled out distinctly in that section 5 of your paper. Also, the specific methodology, the specific steps that you went through to create this climate graph should also be in that methodology, so that someone else could create the climate graph. Just like you read my instructions to create the climate graph, but your instructions will be specific for your city, for Nashville, Tennessee. Also, if you notice, your term paper and your term paper presentation must include graphics. And so you can also use this story map for the map of your city, if you so choose. And again, it's not the most detailed map in the world. You can change the base map if you want. You can have other places located on the city. You might take a wide view just to illustrate the distance that Nashville is away from the nearest ocean, which speaks to its, let's see, 79 minus 37 is 42 Fahrenheit temperature range, which is relatively wide. The only qualitative term that would probably be okay would be a word like relative. So if you say relatively, that means as it relates to other cities in the US in terms of temperature range. But when you say only, that gets into more of a subjective descriptor. Um, okay, absolutely great job, Garrett. I mean, sorry, but don't be sorry. I mean, this is like, wow, man. I mean, this is great. Most students cannot do this. They will not get to this step. Very good map. Looks good. Just transfer. Well, next week, your assignment will probably be the second draft of the term paper. So that's what I'm thinking about for the 11th or 12th through the, for the 13th. No, for the 6th through the 13th assignment, probably being second draft of the term paper. That way, there's almost no way you cannot get this term paper done if you turn in the drafts in time and do this. I mean, you're almost there. You've got your graphic, got your climate graph, you've got your maps, or at least you can make new maps. And now all you have to do is do your analysis. And so, and really your analysis should be an expansion of the climate controls as it relates to the climate graph. So when you get to now your results, so your results would just, this is where you would put your climate graphs and your maps and then discussion on terms of controls of climate. And so this is where you would really get into exploring why that climate graph looks the way it does. Why does it have a wide temperature range? The high temperature in the summer is X degrees Fahrenheit, and so on and so forth. But it should be, it speak to an analysis of the climate graph. Admittedly, this is a less interesting assignment because you're only looking at one city. Normally, you would work collectively and you would compare each city to the other as a group, but we're not in a group. We're not in the classroom. I didn't think that would work out very well. In your discussion, was it just what did you not expect? Was there anything that was surprising? Was there anything you expected to see? Did you expect for Nashville's precipitation to be about 48 inches per year? Did you expect more? Did you expect less? Where does that precipitation amount fall relative to other cities? Now, in Garrett Ross's case, he's got, feel free to expand upon what you've done and say that, there was an analysis done of 5 other cities at various locations. But if I were you, Ross, what I would look at specifically are cities that have a similar latitude to Nashville, because Nashville, the latitude is the primary climate control. Okay, latitude is the most influential control of climate, where a city is north or south of the equator. That's the greatest climate control. So if you look at a city such as Las Vegas, which is, and that's another thing I probably should mention, you should include also in, obviously, in your description of your city, the latitude and longitude, especially the latitude, because it is a climate control. So then we go and compare the latitude of the climate of Nashville, perhaps to the climate of Las Vegas, and they're at the same latitude. Or even looking to the east, Norfolk's latitude isn't that much different from Nashville's. So what Ross could do here is looking across this same latitude is just make a quick comparison, since you do have the data, and say that here we have San Francisco. I believe San Francisco, I know Nashville's at like 38. Let's see, San Francisco. I'm not sure that San Francisco is. Yeah, San Francisco is at 37 degrees north. I think Nashville's at 38 degrees north or so. Let's see, Las Vegas. Las Vegas is 36. I mean, so those cities are all within a very relatively close latitude and to one another. So yeah, 36. So what Ross could do or should do is take a look at the cities across that same approximate latitude and do some form of comparative analysis, not a deep comparative analysis, but clearly there are differences as you go from San Francisco to Las Vegas, to Nashville, to Norfolk. There are clearly differences, and you could speak of it in terms of how Nashville's temperature range, precipitation distribution, precipitation total, and other variables compare with cities that are within the same latitudinal range. So that will be um, a really good addition to the discussion section of the term paper. And Garrett's you already have the content in your map. It's just a matter of transferring it to your paper and then just adding some notes in terms of comparative assessment. Okay, so and if anyone else wants to push the envelope like Ross did and in some way, shape, or form, feel free. I'm not going to stop you from doing too much work. That's not me. But at least Ross can feel as if he didn't, waste his time. I mean, it'd make for a really much better paper. And I do. Speaking of relative, I do compare papers. I mean, if somebody's paper is way better than others, that person's going to get the A on the paper. I mean, I can't give one person an A for doing outstanding work and then you do above average work and you both get A's. That's not going to happen. So if Ross pushes his paper out so much better than everybody else's, then he's going to get the A for his paper. I mean, so it is what it is. Anyway, but let's get best. So very good job, Ross. Everybody else, please use this as an example of the possibilities. So I'm going to just momentarily pause the recording. Okay, so for those of you who happen to be in Nashville this weekend, there was a very significant storm event. Unfortunately, 4 people lost their lives. Is that a fire truck? flash flooding is just very dangerous, as you can see. People were caught completely by surprise by this. And you can see some of the, wow. Very dangerous situation. So from our interest, what is the significance of this storm when it comes to our interest in terms of analyzing and assessing weather? First, let's try to figure out what happened. I wanted to pause take a quick pause for the. Okay, so here we have the weather map for March 27th, which was the date of the storm that hit Nashville, and you can clearly see the this stationary front impacting the region. Here's the warm air being pulled. So we have this counterclockwise rotation around the low pressure system over Texas. And so that's just pulling that very moist air. And at the same time, there was a cold front descending from the north. So we had, no pun intended, but a perfect storm where you had this very moist air coming from the south and relatively cool air coming from the north, and they just stuck together right, you can see it right over Tennessee. They just stopped and just dumped precipitation down onto our region. Bookmark this page. Let's get this page, man. Let's save this page here. Man, I'm just, all right, here. I'm just going to add this to our collection right now of class of mine. Okay, weather and climate. What am I doing? Okay, so again, we had the perfect formula for what happened over the course of the last few days. And I think that I know it was mentioned in the, story, that this was the highest one-day total precipitation for Nashville. Yeah, one of the wettest 24-hour periods in Nashville's history. Worst flooding event since the May 2010 flood. And really, I mean, the prediction was not for anything this extreme, which is interesting. There are many things that contribute to flash flooding, including a change in land cover, which brings us to the discussion of this week's assignment. So let's go to content. Here we are at week 10. And so this week's assignment is investigation. Let me go to student mode 9B, which will take you into some of the, well, let's see, it's right here. assignment 9, which really talks about or introduces the student, that's you, to precipitation as a phenomenon. And so this assignment is not going to be nearly as challenging as last week's assignment. So you have a PDF, and notice as you read the PDF, some of this should be familiar. It kind of reinforces the lesson that we had with Hawaii, except in this case, just really gives you a more quantitative perspective on the rain shadow effect. So basically, you'll do the reading here, and then you'll be asked a question, the general flow, blah, 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 blah. And then you'll pick one of these answers, but you'll answer the question on the answer sheet, which is the answer form, which is here, which is a Word document. And again, as you answer each question, as I said, please delete the answers that you believe are incorrect. So if you believe the correct answer is Southwest, delete the other 3, leave Southwest, and do the same for the rest. So there are only about 16 or 17 or 18 or 19 questions to answer. And so you will again, just go through the reading and answer each question on the answer sheet. And there, so yeah, it's pretty straightforward, like I said, and you'll get a really good experience analyzing precipitation data and understanding, have a little greater understanding of climate controls and how weather stations measure precipitation and so on and so forth. So this week, this is a really good assignment that goes along with what has happened this week. Also, if you notice in the materials, this PowerPoint will go a long way towards helping you with general understanding, but I want to get into this PowerPoint a little bit right now because a big part of a big portion of the hydrologic cycle is included in weather and climate, of course. So the Earth system is an open and dynamic system. It's not closed. So there is interaction, obviously, amongst the atmospheric gases and the hydrosphere in the atmosphere itself. And so let me just give you a few examples. So here is the global water cycle. Almost all of the Earth's water is in oceans in the form of salt water, not easily consumable or useful for human beings, right? Then another portion, or 2.15%, is frozen in ice sheets and glaciers. We can't really get to that either. Then if you notice that there is a significantly higher amount of water underground than there is at the surface, which brings us to this. So here's the global water cycle, and I want you to pay attention to some of these terms. So there's obviously precipitation, and then this overland runoff is basically what is of concern when we talk about flooding, right? And this overland runoff is controlled directly by land cover. Plants, trees, and grass absorb massive amounts of water. But we humans have a tendency to remove grass, trees, and plants and build parking lots, roads, houses, subdivisions. Once we change the nature of the surface, that prevents the ability of that surface to absorb the excess water that is created during storms like the one that struck last week. So our human activities that alter the land surface directly affect how much flooding occurs. And so, as a matter of fact, so speaking of that, here's an article from, ironically, this was just a few days ago. This was March 20th. This is a week before the storm. And the article is entitled, "What the Federal Emergency Management Agency Flood Insurance Changes Could Mean for Nashville Homeowners." So the FEMA and the U.S. Army Corps of Engineers periodically adjust the flood maps for cities. Why do these maps have to be adjusted? Well, as we human beings create more impervious surfaces, that changes or actually increases the risk of flooding, like what happened this past weekend. And so a lot of the flood risk maps are based upon the land cover at the given time that the map was created. So I don't know if I don't know if or when the last time this adjustment was made. I might not be able to even see. I can see. I don't know when the last time the adjustment was made to the flood maps in Davidson County, but periodically these adjustments are made really for public safety, because when there's a flash flood warning put out or announced by the National Weather Service, people, for their own safety, need to be made aware of where this overland flow is most likely to exceed the capacity not only of the earth to absorb the excess water, but also it will exceed the capacity of our built-in sewers and flood control infrastructure. But here's the problem, okay? A developer who builds a Walmart or a developer who builds a housing subdivision must ensure that that change in land surface will not result in increased runoff that will overwhelm the existing infrastructure, whether that be green infrastructure or human-built infrastructure, right? But the landowner is only responsible for controlling and containing the excess water that flows off of his or her own property at that time, not projecting for future growth or land use change, not accounting for adjacent properties So let's say, for instance, a developer tries to get a building permit for a housing subdivision, and the engineers determine that there will be an additional 20 million gallons of water displaced by that land use change. So the developer would have to uh, design a series of sewer lines and also um, retention ponds and other structures that would contain that excess 20 million gallons of water. Um, so would his or her neighbor. Let's say a neighbor has another 20 million gallons displaced, and then another person comes in. So let's say you have 5 parcels of land that will displace, in theory, 20 million gallons of water each, right? They each build in containment systems for that water, which 5 properties times 20 million is what? 100 million gallons of water. So in theory, if the maximum capacity of the infrastructure is 100 million gallons of water, then we should be okay, right? We got 5 property owners. They've each designed infrastructure for 20 million gallons of water. We should be okay. And usually that 20 million gallons of water is based upon a storm amount of maybe a 2-year storm, right? Which might be a certain number of inches of precipitation per hour. Okay, maybe a half of inch of rain per hour over a 24-hour period should be contained by that system. Should be. Here's what happens in reality. You get a rainstorm of whatever the projected amount is that those 5 pieces of property can contain. That rainstorm should produce 100 million gallons of runoff that should be contained. But guess what happens? You don't get 100 million gallons of runoff. You get 120 million gallons of runoff, which results in what we saw last weekend, flooding, and unfortunately, in some cases, people losing their lives. So the principle here is simple. Sometimes the sum of the parts is greater than the whole. The sum of the parts is greater than the whole in terms of flood prevention from time to time. So even though all the math is correct, all these structures are designed to contain 100 million gallons of water. That's what should happen. You know, given a specific precipitation event total in terms of precipitation in inches per hour, that this should work based upon the math. And then you get that amount of rain and it gets overwhelmed, right? But each person did what he or she was supposed to do to get the building permit. Nobody was in violation, and yet you still get flash flooding. And so therein is the problem. How do we account for the cumulative impact of excess runoff if we're only responsible for our individual property in terms of runoff and overland flow? And so even when the authorities try to adjust the flood map so that increases the responsibility of developers to contain more and more water, this changes every day. It's almost impossible to keep up with land use change over long periods of time, even with all the math and engineering models that we have in place. So, next time we'll probably get more into the some of the quantitative uh, assessments for analyzing runoff. But in the meantime, Um, uh, please work on this week's assignment again. It's a pretty lightweight assignment compared to last week. I think next week we'll have the second draft of your term paper due. You can turn in drafts of your term paper anytime. Anytime. You don't have to wait for a graded draft. You can turn in a draft. Dr. Padgett, I want you to look at this, my term paper. How does it look? I might say it looks great. Or I might say, oh, you need to work on this, add that, or what's going on here. So you can turn those in anytime. I think we are out of time. So I'm going to stop recording. Thank you very much for your attendance, and I'll try to get this recording up as fast as possible today.